surface tension. We'll study regarding surface of the liquid in this chapter. A specific property that's observed on the surface only, that's confined to surfaces only. It's known as surface tension. You see, surface tension is the outcome of intermolecular forces only. Intermolecular forces means force between the molecules, but when the molecules are of similar substance, it is cohesive, and when different substances are there, it's called adhesive force. Out of these two forces, depending on which one is greater, which one is smaller, we have the property of surface tension. For a liquid, when we consider a surface film, you see, surface film is the water column between free surface and that plane which is r depth below. This is called surface film. In this film, all the molecules are tense. Tense means they are subjected to a kind of special force because the molecules in the film are not completely balanced by the forces. So, in this film, the molecules are always subject to some additional force. Force is always responsible for potential energy. That means in surface film, the molecules have additional potential energy. This potential energy will always depend on the surface area. You know, for the stability of anything, the potential energy should always be minimum. Here also, this potential energy has a tendency to be minimum, and for that purpose, the surface area always tends to be minimum. That way, in precise, we could say that every liquid film has a tendency to become curved, spherical. Why spherical? Because for a given volume, the spherical surface has the minimum surface area. So, one thing is clear, because of this property, every liquid surface will have a tendency to become spherical. But remember, when the drop is smaller, it's going to be spherical. But when the drop becomes quite bigger in size, then because of gravity, it becomes flat. As far as the definition is concerned, surface tension is equal to the force per unit length. Which force? Additional intermolecular force. Length of what? Length of surface. So, you consider an imaginary line on the surface, and per unit length of that line, the force acting will be known as surface tension. Its unit is Newton per meter. This force will always be tangential to the surface. Now, surface tension depends on nature of the liquid. What does it mean? Every liquid has its own characteristic, and that way its value of surface tension is also variable. For example, for water, this is 0.073 in SI, whereas that for mercury, it is 0.465. Surface tension is affected by temperature also. This is the relation for the dependence of surface tension on temperature. Theta is here temperature. T0 stands for surface tension at 0 degree, and that T theta depends on the value at theta degree Celsius. Alpha would be known as temperature coefficient of surface tension. The equation itself gives you an indication that surface tension will decrease with temperature, and ultimately it becomes very interesting that at a particular temperature, surface tension becomes zero. That very temperature is known as critical temperature. You see, at this very temperature, the two phases, that is liquid and gas or vapor phases, are intermixed. They are not separable. That's why surface tension becomes exactly zero over there. Now, surface tension is responsible for capillary action that we will study in next steps, next pages. Surface tension is responsible for capillary action. When there are impurities, it will also affect surface tension. For example, if you add salt, surface tension will increase by adding salt. If you are going to add detergent, soap, Dettol, etc., surface tension will always decrease. Surface tension gets decreased, it simply means that the internal force for the liquid molecules has decreased, and this becomes facilitating for the clothing, for the cleaning of cloths. You see, when you say that the temperature decreases surface tension, this could be noticed in your daily life. When you take soup and it is hot, not only soup, you might refer to the chart and all that thing that you get in ready in the market. When you enjoy that, when it is more hot, you should be able to explain also that when temperature increases, surface tension decreases. That means the liquid will have less tendency of getting compact, and that will be easily spread on the tongue. That's why the taste buds will be more exposed and you will relish more. You will say it's wonderful and delicious. So you could say that surface tension is also going to ascertain the taste you are having on your